Ultimately, we'd like to graph some absolute value graphs. And when graphing an absolute value graph, a couple things to keep in mind is that first off, these long lines, absolute value, if you can picture those long lines, just to jog your memory, coming together, those absolute value graphs end up looking like the letter V. Now, it might be a V opening up or a V opening down. And you know that the V is opening up if the number in front of the absolute value is positive, and then it will be opening down if the number in front of the absolute value is negative. When graphing an absolute value, the most important point is the vertex. So where these two come together, these two rays come together, that's your vertex. And when it's opening up, or if it's like this, we want to find this point, the vertex, where it's opening down. To find the vertex, the most important point, what we want to do is immediately set what is inside the absolute value equal to 0. So I'm going to take, in this particular one, see how I have x minus 1 inside the absolute value? So I'm going to take that x minus 1 and I'm going to set that equal to 0. So I add 1 to get the x by itself, and I end up with x equals 1. Now that I have the x value, I'm going to come over here and I want to substitute the number 1 into my equation. So let's go ahead and start doing that. Here's my equation, 2 absolute value of x minus 1 minus 3. So I'm going to put the 1 right here. Okay, then let's simplify what's inside the absolute value. 1 minus 1. And so 1 minus 1 is 0. Now that I've simplified what's inside the absolute value, I want to take the absolute value, and the absolute value of 0 is 0. So this absolute value of 0 turns into 0. Now I'm going to finish simplifying, following order of operations. 2 multiplied by 0 is 0, and 0 minus 3 is negative 3. So when I've substituted 1, which came from setting what's inside the absolute value equal to 0, into my equation, I got out negative 3. So I found my vertex, which is at 1 comma negative 3. Now it's not a coincidence, a shortcut that you can use to find the vertex is notice the opposite of the number inside of absolute value. So the opposite of negative 1 is positive 1. And then the number here at the end is negative 3, and it's minus 3. If you use that shortcut, be very careful, again, that it's the opposite of this number, comma this number. So positive 1, comma negative 3. And then I can skip this step. Okay, the next thing I need to do is let's go ahead and actually plot that point. So I'm going to come over here to my graph and go right 1, down 3, and there's my vertex. I do know, because the number in front of the absolute value of x minus 1 is positive, so I do know that there's going to be a V here that's opening up. I need to substitute one more number in for x to find a point, and the number that I substitute should be close to the vertex, not because I can't substitute any number out there. It's just that my graph paper is only so big, and I don't want an answer that's going to take me off my piece of graph paper. So a number that is close to 1 is 0. Again, you could maybe pick 2, or you could pick something else, but something close to 1. So if I substitute 0 into my equation, I'm going to come in here and put in 0. Okay, now that I have my 0 there, I want to do what's inside the absolute value. 0 minus 1 is going to become negative 1. Next, I want to evaluate the absolute value, and the absolute value of -1 is +1. So this absolute value of -1 is turning into a 1 in parentheses. Then let's do the multiplication. 2 times 1 is 2, and 2 minus 3 is -1. So what we found here is that when I substitute in 0, I get out -1. So let's go ahead and plot that point, 0, comma, -1. Okay, so 0, whoops, my bad, undo. Okay, this is just saying find a few more points here. All right, so if I plot the point 0, -1, so right or left 0, down 1, got another point. Again, this is going to be a V opening up. So if I have a V opening up, what I can do to find another point is use some symmetry. And the symmetry is going to take me to 2, -1. If I have a point that is 1 away from this middle line, then I'm going to go here, and so now it's at 2, -1. And finally, I'm ready to draw in my V. So I'm going to go from the vertex through that point, and then I'm going to go again from the vertex, whoops, from the vertex through this point, and I've got my V. Okay, so one more quick example. Just a reminder that to find the most important point first, you want to set what's inside the absolute values equal to 0. And frankly, there's just not much going on inside absolute values in this particular problem. The only thing inside of here is x. But following that procedure, I'm going to go ahead and set this x value, this x inside, equal to 0. There's nothing to solve, so that is the x coordinate of my vertex. Just to emphasize that, I'm just going to color code that. The x is 0. So I'm going to now substitute the number 0 into my equation. So substituting 0 into my equation, I'm going to put the 0 right there. Okay. There's nothing to simplify on the inside, so next, let's go ahead and take the absolute value of 0, which is 0. And now we can multiply. -2 times 0 is 0. And then 0 plus 6 is 6. So when I substituted in 0, again, I found that by taking what's inside the absolute value and setting equal to 0. I ended up getting 6. So let's plot that point, right or left 0, up 1, 2, 3, 4, 5, 6. Okay, there we are. And then some other things that we know. Because the number in front of the absolute value is negative, I know I'm going to have a V that's opening down. We need one more point, and I want to choose an x value that's really close to the vertex, and that was created at 0, so I could maybe substitute in 1 or -1 for no particular reason. I substituted in 1. Okay, so let's go ahead and make that substitution. So here we go. Put that 1 in there. If we find the absolute value of 1, we get 1. So I'm going to replace that absolute value of 1 with the number 1. Let's do that multiplication. -2 multiplied by 1 is -2. And then -2 plus 6 is 4. So when I substituted in 1, I got out 4. That gives me an extra point here. So let's take and plot that point. Right 1, up 4. I'm going to use some symmetry to find one more point. So if this V is opening down and this is a line of symmetry, then if I jump across, if it was 1 this way of that symmetry line, then it's going to be 1 this way on that symmetry line. So from here to here was 1, so I'm going to go right there. And that happens to be located at -1, 4. Now I'm ready to draw my V. So let's go ahead and start at this vertex and go through the point. So boom, go, and then do that again. Go through that point. And now we have the graph of our absolute value. Quick recap one more time is step one, you're going to set what's inside the absolute value equal to 0, and that will give you the x coordinate of your vertex. You substitute that into the equation to get the y coordinate of your vertex. If the number in front is positive, it's smiling. If it's negative, it's frowning. So then pick one more number close to your vertex, substitute it in, plot a point, use the symmetry to jump across and get another point, and now you're ready to draw in your V. I can't help myself. I know this is making the video long, but I want to remind you that there is a shortcut to finding just the vertex, that it's the opposite of this number. So +1, -3. This one is a little more challenging to see it because this is x plus 0. So this one would be 0, 6, and I could skip all of that work.